So guys, welcome to this webinar series. Here's the question. In the print and packaging supply chain, how do we deliver new ideas and innovative practices to continually improve profit and your brand and your quality? My name is Niall Coady, and I'd like to welcome you here to this G7 webinar. I'm the Strategic European Partner to Ideal Alliance, a non-profit global think tank serving the graphic arts industry. I've been asked to come on today and talk about G7, and primarily, G7 is a gray calibration method you may or may not have heard of. It's not a color management system. It embraces international standards like ISO 12647-2, which you may have heard of, and ISO 15339, some of which I shall tell you about in this webinar. G7 is all about replacing CMYK mechanical calibrations with a visual neutral calibration, a standard which is the same successful way we control actual photography in gray balance terms. One of the questions that I get asked an awful lot is what's the difference between FOGRA and the Ideal Alliance and the G7, and people don't quite understand, especially in the European marketplace. And just to sort of give you a general outline, FOGRA is a research institute. It plays a critical role in testing ink on paper. As I said, I have been a PSO certified expert in 2010, so I have undergone the training at the FOGRA. It's everything mechanical and scientific about how we work with print. And they work with the German Print Federation, the BVDM, and UGRA, the Swiss Center of Excellence for the Graphic Arts Community, feeding crucial information back into the TC 130, which is a committee that stands at the heart of ISO standards. These include PSO, process standard offsets, PSR, you may have heard of for rotogravure, and PSD, which is process standard digital. Excuse me. The Ideal Alliance is a non-profit think tank serving the graphic arts industry. It's focused on ISO standards and the development, and it has a real distinct focus on brand color strategy and best practice. G7 is one of the Ideal Alliance specifications, and its role is to make print results more consistent, no matter what the methods or materials that you're using. And especially in the current climate with so many different print processes, both analog and digital, different inks, papers out there, the key really is to make things more consistent, should I say, in terms of results for the brands and things made a bit simpler for the printer to achieve. So the first question is dot gain and TVI, because you hear many references to it. What is it? Okay, it's a mathematical equation. For one, it's figuring out the dot gain on a press in physical mechanical terms, how the ink spreads in a dot when it's laid down on a piece or on a substrate piece of paper. In this example, I say a 50% dot in my color bar measures 75 on the sheet. Therefore, I have 25% dot gain. The most common method, of course, is the Murray-Davies. You might have heard of that. It's an equation mathematical that's used to compute dot gain from density measurements. And if you want to know anything more about that, I reference the site brucelindblom.com on the top of my slide there, and you can see more about the math that sits behind all of this. Sorry, we're skipping ahead too much. FOGRA and the TVI. So how does this all come together? Basically, you're choosing a print condition, okay? Print condition, PSO, PSR, PSD, whichever you're looking at here, they all have several substrate, ink, screen, and process-dependent references. Each paper and process has its own set of rules. As I said, density is a reflectance. It's a measurement of density and reflectance, not colorimetry. So one cyan ink on one site can be completely different to another, especially in the packaging industry where we see huge variances in the colorimetry of the independent inks. So the point is that FOGRA and TVI is very process specific, okay? So you choose your print condition based on these mechanical standards, And you can go to eci.org and download that profile. You can set up your proof using your GMG or your EFI RIP. It's all based on this FOGRA print standardized target. You calibrate your press using the mechanical aspect of things. So obviously it's based on a curve shape that's defined in this case by the ISO 12647.2. Paper type with a specific screen ruling that it's going to use and colorimetry for the endpoints. You're going to process control your output dependent on that ink and substrate to the press, and then you're basically going to take a look at what happens in TVI terms. So TVI doesn't control tonality. So in this particular example, both patches have the same TVI, but different tonality. Think of tonality like a linearization scale from 1 to 100 and getting it in equal steps. So in this case, we were looking at 50% black ink at 20% tonal value increase on the press. So how is this possible? Essentially because TVI doesn't control tonality. And it's a ratio of reflectance, as I've said before. It's not an indicator of the appearance of the actual color. It doesn't control gray balance. So TVI itself, quite simply in this particular example, where we have 50, 40, 40, let's say, of CM and Y to make up a neutral CMY, it's not equal simply because it doesn't control the color of the gray balance. So because gray is greatly influenced by the trap of the ink, the opacity of that ink, how it blends, the sequence that it's printed on the press perhaps, and most importantly by the hue of the different inks that are being used. So this results in this is a result. So this is a live look at an example that I've used for the purpose of this webinar today, to show you where in a print environment, I have a very acceptable CMYK numbers and, very acceptable dot gain numbers on the bottom, but in the middle, my gray ramps and my gray balance are completely thrown off. Gray balance does not occur naturally for CMYK on a press. So if we get our mechanics all in a line, we are not guaranteed to have natural neutral gray balance on the press. We have to use something like G7 neutral print density curve to actually achieve that. So gray balance in G7, that's controlled by the G7 calibration. It is at its heart a gray calibration system. And we meld that together with standards like that is set by ISO 12647-2 for the different paper types. And we can blend those together. And that is essentially why they created ISO 15339. This is characterized reference print condition. This is the new way to look at things. A print process agnostic way of looking at 7 agreed print conditions that we can use in our printing environments, again, for any particular print process. On top of which, because it's paper relative, we can use another ISO standard, 13665, to adjust those standards into substandards for your custom paper types. So this is standardized characterization data that can be used inside your proofer. I can make a proof based on measuring a paper and adapting it to one separation standard. And I can get some consistent results from that. I can also get a stained proof that looks like it would in output. Some of the standardized characterization data, interestingly enough, this is where we get the G7, one file, one separation, one calibration, one aim point print anywhere slogan. It actually means that we're able to roll with the punches, use different paper colors that might not comply completely with the standards, get us a proof that matches more what we can achieve on the press, and do things quicker and faster with this technology. So just to describe, you've got everything here, a nice little visual here. This is showing common tonality, neutral appearance between newsprint on the left-hand side, running right through up into uncoated papers, super calendared papers, into CRPC 6, which of course is very much like FOGRA 39 and 51, and XCMYK, which is a highly saturated CMYK color gamut. Also in the FOGRA terms, FOGRA 53, an extended ECI CMYK target space They're all common. They all use the same endpoints, and therefore anything that we use just with different, words or references, they're all really the same. Think of G7 at the core of this really great standard, ISO 15339. So we've got all of the gray balance and relative neutral density numbers for each one of our characterization sets, but we're also taking into consideration the solid overprints, the RGB, and the solid primaries, all in that. So those characterization data sets, think of them as more information to control our print better so that we can actually achieve a more consistent result. Some people ask me, what's all this gray stuff about? Like, why is it so important? And I simply answer them and I say, look, it's all about how our eyes work. Chromatic adaptation is a human visual system. It's how we change essentially for how things are illuminated or surrounding influences in color. So in isolation, I can look at each one of these pictures and I can see that the road is neutral gray to our eye in isolation. Together, we might choose one particular one on the right-hand side and say that that's more neutral than the others. But as I say, in isolation, when we're looking at something, our eye has this way of balancing what would be the neutral point on the sheet that we're looking at. So it's interesting how our eye works, and it's interesting that G7 actually works to scientifically calibrate your press to the way your eye is going to see that neutral color. And that's really, I think, the key to getting brands and people who are looking at the finished results to really be excited about what they're seeing. I did allude to this before, but we have this technology. It's an ISO standard called 13655 SCCA, substrate corrected colorimetric aim. Essentially what this is an ability to take a data set, let's say CRPC 6, and adapt that for a color that might be away, like a little bit away from the standard reference for CRPC 6. It might have more or less optical brightening agents. Whatever the case may be, if it's over a delta E of 2, I can use this technology to tweak the numbers inside the data set to expect a response based on the actual white of the substrate. So in essence, gray has been used to control photography forever, and the idea here is we're going to control the CMYK the exact same way, and this has been shown and proven to deliver some fantastic results. So as part of my presentation into this, I've been able to put together here for you a couple of practical examples. So this is a practical example from one of my clients. Reflex Labels is a narrow web Flexo printer in the UK. They've got 9 sites. They deal with a lot of big promotional brands, shopping retailers. And what they wanted to do as a business that has over 1,000 specifications running on GMG proofers and ColorLogic color server systems, they wanted to cut down on the amount of profiles and different proofing specifications that they had. And they came to me and they were talking to me about this. And I explained how G7 worked. I said, listen, have one file and have multiple outputs and just basically have plate curves. And this would give you a very exciting and fresh look at how to control this environment. So they tested it. And vellum is the substrate on the left, thermal and semi-gloss. Vellum is a classic example of a substrate that they expect a very bad result from. They say it, delivers not very saturated results and has always been the poorest of the lot. When I used G7 on this, they saw color off of the sheet that they'd never seen out of this specification, and we're very excited about it. We did, as I say, this represents 3 plate calibrations in their Kodak NX workflow, and just printed out on a standard narrow web, Marcandy narrow web press. So they like, for instance, the fact that in G7 terms, we only need 300 patches to do a full G7 calibration. But in fact, they like it even better that we only really need columns 4 and 5 to make that calibration really work, because we're only calibrating the neutral print density curve for CMY and black and the tonality the same. So we can use a very small color bar there on our work to actually achieve a good calibration result for G7. Furthermore, I did allude to common neutrality before. This is the highlight contrast patch, and that is the quarter tone 25% CMY and black patch on columns 4 and 5. And that is what's consistent throughout a 15339, the characterized reference printing condition data sets, the 7 of them. That's the common denominator between all of those outputs. And that's how we get the common neutral appearance between everything. If we look at how we control G7, that gets even more exciting, because printers can look at these two patches here, which is, let's say, a 50% black and a 50% CMY. And we can drive with the TESCON instrument shown here, using a best density method, we can actually drive the entire make-ready process control for the press from that patch. So when we measure that CMY patch, if it's a little warm, a little too much magenta, or a little too much cyan, for instance, it shows you directly here what to do on the press to get you back to the condition that your press was when you first calibrated it. So it's really easy to control, and we like that too. The real thing is the results. And again, this is a real example, as I've said to you earlier. So in this particular case, you're seeing CMYK numbers, they pass. The RGB numbers, they pass. The dot gain, a pass. Neutral appearance, passing. Happy brand and a happy printer. I went to, I've been involved with the printers with HHG and Asda, Walmart for some time here in the UK. And this is a practical example that I can show you. On the left in November, where we had the numbers that you can see quite clearly here, were sub 50% off of their scoring system that they had set up as a quality control system. They were hitting the CMYK numbers. Everything was absolutely fine, except their grades were failing, and they were having problems. And they came to me and they said, look, how can we address this issue? We really need to, because we're seeing common differences in the work that's being reproduced. It's primarily in these neutral areas, and we really need to fix it. I went about in the December and January of putting together a program for them for G7. They implemented that, and as you can see on the right-hand side, up today, we're doubling those scores. That's G7-based calibration in a European environment using 39L separated files, using a G7 calibration, and those are the numbers that we're seeing on the right-hand side. And they've seen the lights. Once you get your head around the idea of calibrating a gray, you'll never go back, because you'll see better results in your press than you've ever seen. And I believe with somebody who has a great deal of experience and many, many years under his belt in calibration and being involved with products to calibrate using TVI, I'll tell you right now, G7 is a godsend. Thank you, everybody, for your time today. This has been a nice and easy webinar. I think I had probably thought to myself I was going to have discussion within the presentation the way I had first anticipated when I built this presentation, but obviously talking to myself, it's been quite quick. So I hope you have lots of questions for me, either on or offline. Fire away.